So today's session will discuss what are the differences between Docker Swarm versus Kubernetes. So one of the common question people will ask us is, already we are using Docker. On top of that, there is an orchestration solution called as Docker Swarm. Okay. Then people will ask us why we need to go for again a Kubernetes. Again, it's also a like a orchestration kind of tool itself. Okay, so already Docker is there. So then, like we should able to explain, okay, what are the features Kubernetes having, okay, and that's Docker doesn't have. But what are the similarities? What are the similarities between them?
Swarm and Kubernetes are both our orchestration
Yeah, both
tools.
are orchestration kind of tool. What is the meaning of orchestration here? So what is the concept of orchestration is automatically we can scale up the containers, we can scale down, auto scaling, stop, start, self-healing. So these all comes under an automation kind of thing. That tool is called as an orchestration. Okay. So even if I tell cloud is also is an orchestrator itself because automatically we can create the VMs, we can scale up, we can scale down, we can shut down. Okay. So all this we can manage or not. But
Yes.
these are the Kubernetes or Docker Swarm at what level it is doing? So at what level it is doing that kind of orchestration? At the
Master.
VM level it is doing.
Okay.
AWS, all these are doing at the AWS are doing at the VM level. Okay. So whereas Docker or Docker Swarm or Kubernetes is doing
In
at the
instance
container
container
level
level.
it is doing. At the container level it is doing. So hence here if someone asks about Docker versus Kubernetes, okay, there is no difference between Docker versus Kubernetes. Both are two different solutions. Because Docker is a containerization kind of solution, Kubernetes is on top of that orchestration kind of solution. But we have a Docker Swarm versus Kubernetes we have. Okay, so we have the Docker Swarm versus Kubernetes. Both are the orchestration kind of tools. Okay, so what is that meaning of orchestration is it's a better term than the automation. Automatically we can scale up, we can scale down, we can schedule or we can auto scale, load balance, self heal. Okay, so all these we can do. Even termination also we can do. Okay, so that kind of automation we are going to get it through orchestration kind of tool. But why we are not using Docker Swarm is Docker Swarm may be a better solution for the small or maybe very low medium kind of thing, not very even high medium also maybe in the future they can scale up. That is the reason a lot of companies are going for the Kubernetes. Okay, so Docker Swarm may be a better solution for the small or maybe like little medium kind of things. It's not for the production workloads. For the production workloads, is recommended to go for
Kubernetes.
it's a Kubernetes itself. What features of the Kubernetes are making that we'll discuss. Okay, so now if I go for the Docker Swarm, there is no, so suppose all these features are there even with the Docker Swarm also, but what is the problem is it's not proven at the production level. It's not proven at the production level, it's not proven. Okay, so I'll tell one basic example. Say, suppose we have a small boat and a very big ship in the sea. Which one is better? Boat is very risky or not? Okay, so I can go, I can like it also. We can travel means, but it's not at the production level. Okay, so definitely we need a very big ship itself if we want to travel more. Then for the production applications also, Kubernetes itself will manage. But here, if I talk about auto scaling, okay, so Docker Swarm also may support. Docker Swarm also will support auto scaling, but not
Yes.
at the level of or not at the advanced features of what Kubernetes is providing. Okay, so Kubernetes supports horizontal pod autoscaler, vertical pod autoscalers, cluster autoscalers, this kind of advanced features we have. Okay, so that's what is the advantage is for the applications why we are going for the microservices is I want a sudden spike of auto scaling. So I'll tell one use case. Say like yesterday maybe at IPL match is finishing. Lot of views may comes to that maybe Hotstar. If that is a microservice based application, they want to scale up within seconds or within minutes itself. Okay, so that kind of scalability with the VMs, minimum how much time it will take? If they scale up the new EC2 instances also, minimum how much time it will take? That application will take minimum 5 minutes it will take. Okay, but within the time the match may be finished or not.
Yes. Yes, sir.
Okay, so that would be finished, right? That's the reason auto scaling need to happen very fastly.
Yes, sir. Right.
Okay, so that's the reason we are going for the microservice kind of thing, and the containers can fast very fastly, but that orchestration manually doing is not possible. Okay, so then the second one is the richer networking and ingress also we have. So ingress controllers, layer, so all these features now Docker Swarm is trying to implement, but already proven solutions are with the Kubernetes. So people will come with one feature of Docker Swarm, even we have this with the Docker Swarm, but what is the problem is no one has proven that or no one has used that. But already Kubernetes has been proven. One of the best solution for that is everyone are using Google workloads, right? Most
Yes.
of the Google workloads, like maybe Google Web Engine or Gmails, most of these Google, YouTube, all these are being hosted on the Kubernetes itself. Means nothing to prove more than that, right? The scalability is the Google is the like most of the Google products itself are the leading kind of thing, and those have been deployed on top of
Kubernetes.
on the Kubernetes itself. It's a very richer networking and ingress kind of things also we have, and even security is also more. Okay, so then we can maintain persistent storage. Even we have the volumes, but not at the enterprise level. That is okay. So those are not at the enterprise level. Okay, and we have Prometheus, Grafana, all these also. Okay, very advanced level Kubernetes is supporting. With the Docker Swarm, even if they tell that it supports this feature, but it's not proven it, we can tell. But Kubernetes is already proven. Okay, and it's cloud native also, and multi cloud also it supports. Okay, on premises we can use, or maybe we can use in the cloud also we can use. Okay, so now auto scaling, load balancing, ingress level load balancing kind of thing, RBAC role based access control, persistent storage, monitoring kind of thing, native support, multi tenancy, extensibility, and deployment strategies. All these are very advanced level we have with the Kubernetes. Only the challenge is it's little complex kind of thing, but that complexity itself is going to give the job for us. Okay, it's not so simple. Developers automatically may not understand this. That's a little complex kind of thing. Okay, so that's we need to manage. That's going to give the job. But whereas Docker Swarm is very simple kind of thing. The Docker Swarm is very simple. Okay, even we can initialize. Okay, so very fastly we can initialize also. So that is also main advantage to use the Docker Swarm is recommended to use. We have a small application or we have a POC kind of thing. For the smaller setup, we can go for, okay, so we can go for a Docker Swarm. But I want at the production level better to go for Kubernetes, and which is easy to set up. Okay, so Docker Swarm is easy to set up, but with the managed services, What is the managed services in AWS? We have EKS, Elastic Kubernetes Service. Okay, so in Azure we have AKS, Azure Kubernetes Service. Okay, in GCP we have GKE engine. So like this, even in Oracle Cloud, IBM Cloud, everywhere we have the managed service. That's so easy to use. Okay, previously it's maybe little complex kind of thing, but now it's very simple to use also. But the architecture little complex, but it suits for the production scalable applications. Most of the financial based applications, large scale applications. Okay, so definitely they're choosing microservices itself. Previously, we have the monolithic applications. Now, like microservices, we are going to migrate. That monolithic to microservice kind of migration itself is generating a lot of revenue for us, for the projects also. Okay, but we have a lot of benefits. Why we need to go for the microservices? We'll discuss those also. But in order to deploy the microservices, either we'll use Docker Swarm kind of environment, or we are going to use Docker Swarm or Kubernetes or OpenShift kind of things also we are going to use. Okay, so on top of
So
that,
what's OpenShift, sir?
OpenShift also is another product which is a competitor to Kubernetes. Okay, so that's OpenShift also is one of the leading orchestration kind of tool.
And this is
Enterprises may prefer OpenShift, but why they're running behind Kubernetes is Google is there in the backend.
okay.
Anyhow, Google need to use, right, that they will be releasing good support all these also. That's the reason people are safely using
Kubernetes.
Kubernetes. Otherwise, definitely enterprises may prefer to go for OpenShift. But
OpenShift.
even OpenShift also is market is there. But if you know Kubernetes, OpenShift is 90% same.
Sir, when Google has this GKE option, why are they going for Kubernetes? They could go for
No, no,
Google
I'll
because
tell one example. Say suppose Oracle is there or MySQL is there. That's all supported in all the clouds or not.
yes.
So like this, they made it a cloud native kind of thing.
Okay.
Okay, so that's Google. Google has take the decision. Okay, they want to support to the community.
Hmm.
Okay, because they also getting success from all these companies, from all these, right? That's the
Yes.
reason to help their deployments also. Google made it open source.
Okay.
In 2014, they made it public available.
Okay.
So they can sell it as a product, but they want to contribute to the world also. That's the reason they made it open source.
Okay.
Okay, and cloud native also, any of the cloud also, they can integrate that.
What is cloud native, sir? I mean, I've
Cloud
missed.
native means like even on premises we can use, and the application also. Most of the people are asking for make it ready for cloud native means it's maybe deployed on AWS or it may be deployed on Azure. Like this, people are asking.
Just keep it ready to deploy anywhere. That is
Deploy anywhere. Okay. So then orchestration also like independent. It required a container runtime. I'll tell one example. AWS, what is the hypervisor it is used?
hypervisor. It's
So Gen source like that.
okay.
Azure is using Azure is using Hyper-V in the backend.
Hyper-V. Okay.
Say in the same way, here also, like Docker Swarm, by default, it uses Docker only.
Okay.
But Kubernetes is not only Docker is the runtime. Okay, there are a lot of competitors to Docker also. Kubernetes supports multiple container runtimes. Do you get that? That means what is the hypervisor used by AWS is GenSource.
Zen.
Okay, but GCP is using like a KVM kind of thing. But
KV.
KVM, kernel virtual machine.
Okay.
But when it comes to Kubernetes, Kubernetes backend, it's not only Docker it supports. Okay, container D is there, some podman, there are different container runtimes. But the most popular container runtime is
Hyper-V Zen.
no, container runtime. Those are the hypervisors.
Okay. Dog. Google.
Docker or container D, CRIO, podman. Like this, we have the different container runtimes. Whereas
Okay.
Docker Swarm supports only
Docker
Docker
database.
itself.
Okay.
Whereas Kubernetes supports multiple container runtimes. In the
Okay.
middle, some news came like Docker is going to be stopped the support also. Kubernetes is going to stop the Docker, but still they're continuing.
Okay.
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 Then DNS also, service discovery also is very powerful compared to Docker Swarm. And load balancing also, it supports only layer 4, whereas this supports at the application level also. And no native support for HPA, all these, whereas HPA, VPA,
Auto scaling.
yeah, auto scaling,
Yes.
all these also is supported. Storage also, basic volumes are there, but that's not at all suitable for the production.
Okay.
Okay, so then config management also, config management, but limited features, all are there. So I'll tell we have a car, remote car, small car, and we have a very big car. Like I have all the features means, but it's not a production scalability.
Right.
Okay. Then even monitoring also we have a very rich support is available because the backend who is there for Kubernetes,
Google.
Google, that is leading the things. Lot of market support also is there for the Kubernetes. Most of the deployments going forward next to 5 to 6 years also, all the applications will move to microservices and we need to deploy to Kubernetes. And definitely we should have the capability to troubleshoot, optimize, secure, deploy on the Kubernetes. That itself is going to give the job for us.
Sir, Kubernetes also, most of the interviews are asking mostly about Kubernetes. I mean,
Yeah,
is
that
that
is the reason. That is the reason Kubernetes.
being a DevOps engineer also and day to day we have to do
Yes, yes.
work on
I'm there last 7 years, 8 years. I'm teaching in lot of interviews. I'm doing working. Still, it's a new thing.
Okay.
It's a very vast kind of subject.
Okay.
Okay, so there are hundreds of Google developers also working. Lot of some. It's a open source right now. Some lakhs of companies also,
Contributors.
developers also contributing.
Yes.
Okay, so which is having good community and ecosystem.
Kubernetes.
Kubernetes having a huge ecosystem is available compared to Docker also having good, but nowhere comparable with Google. Okay,
Docker.
and
Yeah.
what is that CNCF is? It's a cloud native computing organization. Okay, so most of the cloud native kind of and because all the ISOs, all these like we need to have a global standards, right?
Yes, sir.
Like if we go for a mobile, also mobile need to support multiple vendors like that they're going to give. Like this here also at the application level also, this is going to support the cloud native kind of projects. And what like Google done is they given this to CNCF community, they given that Kubernetes. That itself is going to manage. Okay, so it's a one of the open source kind of software foundation. Okay, mostly Linux will manage and they given that code also to them.
Okay.
Okay, so that's the reason massive ecosystem we have compared to Docker. And always production level, it's already proven. Google itself is the solution for that. very high scalable applications we can deploy, and multi-tenancy also. Okay, so for multiple teams, multiple projects also we can provide. And we have a lot of custom, that means extensions also, a lot of extensions for Kafka kind of thing, or for the your application specific, this kind of support also is available.
Okay.
Okay. So then here Docker Swarm is the best solution. We have a microservice kind of application, but very small kind of thing, no future scope also, very limited kind of user base. Then better to go for Docker Swarm. Okay, so maybe proof of concepts like this also, but large scale, and maybe in the future also I want to scale up more, then better to go for Kubernetes. Okay, we want the high availability, scalability, complex deployment strategies. We'll discuss what are those blue, green. All these are supported by,
Kubernetes.
yeah. So then Docker Swarm is initially to understand the Kubernetes, all these we have. But whereas for the production scalable applications,
We are going with Kubernetes.
Kubernetes, because these you need to able to explain confidently, and a lot of people will ask why we need to go for Kubernetes. So coming back to the Kubernetes architecture, say in the Docker also we have manager and worker, right?
Yes, sir. Master slave.
Yeah. So now here anyhow any cluster will have that kind of master and the slave kind of architecture.
Okay.
Okay. So but like here also we have like master and worker kind of components. So there we will calling as manager and,
Worker. No. Worker slave. Yeah.
yeah.
No.
So then here in the manager, we have a lot of components. Even in the Kubernetes also, sorry, in the Docker Swarm also, we have all these components. But these all the different components we have in the like a master. But the master, another name we are calling is control plane.
Okay.
Okay. So that's we are going to use like a control plane. The control plane is nothing but
Master.
is the master itself. Okay, so now in the control plane, again we have important 4 to 5 components we have. Okay, so one is Kube API server. So mostly we have 4 components. Today try to understand what are the components we have and the basic purpose. Going forward, when we set up all these, we'll understand. Okay, the in the day one itself you don't understand the complex architecture. Okay, so now the first component is Kube API server. The API server says, suppose even if you use Docker commands, Docker API will understand all those. In the same way, API server is the front end of your cluster. That's like in the AWS we have APIs itself, but that AWS SDK will listen that either from Terraform or from CloudFormation, GUI, CLI, or programmatically. Okay, everything is going to manage. Uh, Everything is going to manage through API server itself. That means if you type some command or from dashboard or from a third-party tool, finally from the Kubernetes, who is that spokesperson kind of thing?
API server.
API server. API server will listen that request, will understand, and will deliver what it wants.
Single source of truth.
Yeah, so that's for the cluster. That's maybe through CLI, dashboard, third-party tools, APIs. Anything will hit the
API server.
API server and expose those all the APIs, and we are going to communicate, authenticate all that with this API server. Even in AWS also, if you launch an AWS EC2 instance, when we click on the launch button, that is going to communicate through
API server.
AWS SDK itself. That's maybe a web service kind of thing. So here also we have the API server.
So what is REST API, sir?
REST API is one of the in the web services. In order to set up, previously we have the SOAP kind of protocol, but now we are using the REST APIs. Okay,
Okay.
so representational state transfer application programming interface. Now, you say
Okay.
suppose you do the UPI transfers. UPI is also uses the REST API itself. Say suppose you are using Phone Pay to your bank. It's maybe one API kind of thing.
Okay.
Okay, so that's you are authenticating to Gmail, right? From
Yes, sir.
Mintra something or maybe ChatGPT to Gmail. Okay, that is your ChatGPT application is communicating
Uh,
with the Google API. Okay, so like these two servers can communicate and transfer the state, all this programmatically using these REST APIs, it is going to happen. Between the communication between two B2B applications or client server kind of applications, the communicating is going to happen through REST APIs. Okay, so now even from the kubectl, if I run, say normally Docker commands we have, right? In the same way, if I run any command in the Kubernetes also is going to communicate through Kube API server. Okay, then second one is etcd. Etcd is nothing but a database kind of thing, but it's a NoSQL kind of database. It's a NoSQL kind of database. Okay, what is that meaning is it's a key value store. All the cluster meta information. Normally, if you have a student project, if you do student database need to store somewhere or not.
yes, sir.
Okay, so that's like here all the cluster information need to be stored in one key value store kind of database. That meta information is going to store in
ETCD.
the etcd. Etcd is not a Kubernetes component. It's a third party kind of NoSQL, just like a MongoDB we have. Like this is also one etcd is also most of the clusters internally inbuilt. They're using this kind of database. Okay, all the information regarding that cluster information is going to store. Okay, so then like kube scheduler, what it is going to happen is uh, like a in the Docker Swarm also, when we run 6 replicas, here we are going to run on the 3 nodes. Assume we have like it need to schedule on which node it need to run. Okay, assume I have 3 nodes, like I have 6 pods I need to run or 6 replicas I need to run. We need to take the decision on which node those pods need to run or containers need to run. Say, suppose I want to run 10 replicas. What is the role of the scheduler is scheduler will decide on which node. So now assume you went to a multiplex. Okay, so which theater you will choose based on the number, right?
Yes, sir.
So that's they already scheduled that. That is the reason you are going to that theater. In our cluster also, we have the multiple nodes. What is the scheduler decision in the Kubernetes is where that workload need to run. In the Kubernetes, that workload is called as pod, but that decision is taken care by,
Cube scheduler.
yeah, kube scheduler. Okay, based on the node capacity, affinity, anti-affinity, these all will discuss. Okay, so you are getting one term called node selector. Already it's selected for you. Say maybe like a screen 2, screen 3. That is already assigned to you, right? As a node selector. That's already selected to you. That is the
Yeah.
reason you are going to
Go to that particular.
that. But here dynamically that scheduling is going to happen.
Okay.
Okay, so then we have Kube Controller Manager, watches all the node failures or maybe like pod failures, job service endpoints, all that. If any of the node is failure, that it will verify and it will try to remove it from that controller. Or if your number of pods are not running as per the expectation, the desired state need to be maintained by these controllers.
Okay.
Okay, and optionally we have the cloud controller also, because most of them we are using cloud, and we want to use the cloud storage, cloud load balancers, cloud networking. Okay, auto scaling also in the cloud. For all these, we need to go for,
Control manager in cloud.
yeah,
So basically, we have one cloud control manager and a cube control manager.
yeah. So that is Cube controller. We are getting by default these components only.
Okay.
But based on your AWS cloud, I want to use AWS load balancers or AWS maybe IAM kind of for the authentications. That's by default we are not getting on the Kubernetes. If it is AWS level cloud controller is required. If it is Azure level,
Yes, you.
okay, it's a cloud controller. This is the previously we used to set up. Now with the managed service inbuilt it will come.
Okay.
So inbuilt it is coming. Okay. So that's we are going to use the load balancers or volumes, all this from the cloud. Say load balancers, we have ELB, right? For volumes, we have EBS kind of thing, IAM, okay, cluster auto scaling in the backend, we are using EC2 kind of thing, or Fargate. All these we are getting through the cloud controller we are getting. Okay. So then, like these all the important components in the
Kubernetes.
master wise, or master itself will called as control plane. Okay, in the master mostly we have four important components. First one is control plane, like component is API server, then scheduler we can call, or cube scheduler, then etcd, then cube controller we can tell, or cube controller manager, and optionally we can tell cloud controller manager also.
Sir,
Cloud
ఒకసారి
controller
Google
manager.
Google ఒకసారి ఇమేజ్ చూపించారు సార్ ఇది ఆర్కిటెక్చర్ Kubernetes.
Yeah, yeah. After node components, we'll discuss. Okay,
Okay.
on the worker side, okay, or on the node side, okay, we have kubelet. So kubelet is agent, because from the master it need to report. Okay, so that means, say suppose I want to control something, so I want to see something in my remote location, I need to have a CC cam or not.
Yes, sir.
That is my agent. Okay, but here I want to control 10 nodes, and each and every node, my agent should be there. What is the role of that agent? It need to report to, it need to report
The control panel.
to the controller. To the API server, mostly it would be reporting. Mostly to the API server, it is going to
Repeat.
report. Okay, so that is the responsibility of,
Kubelet.
yeah, that is the responsibility of the kubelet. It's an agent service. If that is agent is not reporting, what is that meaning of manager wise? From the manager wise, what is that meaning?
Nothing is happening.
That node is out of the cluster.
Okay.
The manager will assume that server is out of the
Cluster.
cluster. Okay, so that's we need to make sure. That's we need to make sure on the every node that agent should be running. Okay, and with whom it is going to communicate is with the API server. It is going to communicate with the API server. It is going to
Community.
communicate. Okay, and ensures all the pod state, all these also as per the expected state. It is going to manage. Okay, so that is the responsibility. And anyhow, we require a container runtime also. That's not only Docker, CRIO, container D. Now Docker is also they're telling depreciated kind of thing.
Oh,
Okay, so now inbuilt we are getting a container D kind of thing we are getting. On top of that, we'll have the pod. Say normally in the containers we are calling, right, but in the Kubernetes it's called as pod.
pods.
I'll tell one example. Normally in the virtualization, we are using the VM, right?
Yes, sir.
But in AWS wise, we are calling that as
EC2 instance.
EC2 instance. Docker wise, it's maybe a container kind of thing, but the managed from the Kubernetes wise is it's a pod itself.
Okay.
But technically, if I create an EC2 instance, it is creating an VM in the gen source or somewhere.
Yes, sir.
But even if I run as a pod also, it's running as a container itself.
Right.
Okay. But pod is an encapsulation of that like a container or one or more containers also we can have. That storage network encapsulated into single entity, that's called as
Pods.
pods. That's called as the pods. Okay. I hope you got it right. The smallest deployable unit in the Kubernetes is pod.
Okay.
But pod is an encapsulation of
A
one or more
container.
containers, their network, and storage. Okay. So sometimes one pod, one container would be there, or one container, one pod can contains
One multiple containers.
multiple containers also. But if you understand the microservice kind of thing, we want to keep it very lightweight.
Yes, sir.
That is the reason mostly 99% will use
Containers.
one container in one
One pod.
pod. There are some special cases. There in that use case itself, we are going to use
More than one
yeah,
containers
not
inside.
more than maybe two containers we may have.
Okay.
Because keeping more containers again is little challenging kind of thing.
Heavyweight.
Yeah. Okay. So that's again we can go for a monolithic itself, right? Why we are splitting into microservices for the lightweight itself.
Right.
But there are some special use cases. We'll discuss that. Why we need to go for the multiple containers, because both the containers want to share the same shared volume or networking is my requirement. Then I'll go for multiple containers in the same pod. Okay. So then we have deployment, stateful sets, daemon sets, all these we'll discuss. And services also we'll discuss in the tomorrow session. Okay. So then, like once we submit some kubectl command something, normally we'll run docker run kind of commands, right? Assume here I'm going to run kubectl apply -f. Then like this is kubectl is the command line tool. That command line tool will communicate with Kubernetes. From the Kubernetes, which component will comes? It is going to communicate with the API server. API server will understand that instruction. Then, like it checks the etcd or it writes the data into etcd, and scheduler also is going to assign the parts on the nodes. And kubectl will listen that request and will execute that and inform the status what happened, whether it's success or failure. Okay, all that it runs. And networking is going to set up with the Kube-Proxy. Okay, so even very important component on the node side is Kube-Proxy. Okay, so now on the node side, so networking rules and service discovery, routing, all these are going to be taken care by Kube-Proxy. Okay, so one of the important component on the agent is Kubelet.
Kube-Proxy.
Kubelet is the agent component. But for the networking, what is the component we have is
Kube-Proxy.
Kube-Proxy. What is the responsibility of the Kube-Proxy is
Network
yeah,
rules and
all the networking rules and service discovery we'll discuss more also. The Kube-Proxy also plays a vital role. So now, can you tell me what are the components we have in the master and
in the master
now
plan
here we have a control plane.
API server, we have
In the
etcd,
control plane, we have what are the components we have is API server,
etcd.
yeah, Kube scheduler,
Okay.
controller manager, then etcd, cloud controller manager. So these are the components we have. Okay. Then what we have on the worker node.
Kubelet, Kube-Proxy.
Yeah. So and one more important small point is very long back that worker node is called as minions. Okay. So no one is using now minions the term, but in the
Okay.
very early days that worker node is called as
Minions.
Minions. Okay, so tiny kind of things, right?
Yes.
Okay, so but someone may ask you in the interview what is the meaning of minion is nothing but is the previous worker node name. Okay, so on the worker node or minions, what are the components we have is so kubelet,
Kube-Proxy.
a Kube-Proxy, one container, runtime is required.
Container runtime. Okay.
Yeah, that's on top of that we have the parts, but we don't create the parts manually. We have the higher level of objects than parts. We'll discuss those. Normally, even in the Docker Swarm also, we didn't create the containers. We'll create services or stacks, right?
Yes.
Okay, so service itself will, if I give 10 replicas, it creates 10 containers. Okay, so these all the components we have in the,
Worker node.
yeah, in the worker node. Okay, so then the parts also will discuss all these working while working will get, and this workflow also people are asking in the interview also. Once you type something on the API server, what is going to happen?
Sir, you share this file in the group.
Yeah, yeah. These all copied from ChatGPT only. I'll share that. No issues.
Okay, sir.
Okay. So now here, what are the things is like we have in the previous videos are there, right? I shared
Yes, sir.
most of them. I copied from the Kubernetes official documentation.
Okay.
That's the reason I took this from the ChatGPT or from this I have written.
Okay,
Okay.
sir. Nice.
The that both of them like it's mandatory. You need to finish those videos also.
Okay.
Okay. So then once the user hits the API server for any command, that
Okay.
kubectl will authenticate and communicate with the Kubernetes cluster, but the front end is the API server, and API server validates and writes the desired state to etcd or retrieves the data to etcd, and scheduler also assign the parts to nodes. Okay.
Okay.
Then Kube-Proxy will set up the network routing to the pod to reachable, and the controllers will monitor that state and whatever the things we have, we can control. If the desired state is not there, it will create those pods.
Okay.
Okay. So
Okay.
this all the workflow also we need to explain. Okay. So
Okay.
then API server, etcd, scheduler, controller on the worker nodes, those all is going to run. On the worker node, we have the kubelet, proxy, container runtime. On top of that, the parts. On top of the parts also, we have a lot of objects. Those also we'll discuss. So we have the deployments and stateful sets, all those also we'll discuss.
సార్ ఆర్కిటెక్చర్ ఇమేజ్ చూపిస్తాను నాకు.
Yeah, yeah. So better to follow official documentation.
Okay.
So now here we have the Kubernetes. Okay, so now here this is the control plane. In the control plane, like mostly the users are going to hit it from API server, then it's going to be etcd. Etcd is nothing but it's a database kind of thing.
Okay.
Okay, but it's not a RDBMS. It's a NoSQL kind of database. Okay, and even in some of the production kind of clusters, we don't maintain etcd on the same server also.
Why, sir?
It should be distributed.
Means distributed among the teams.
Not among the team, not from the master itself for the high availability and scalability.
Okay. So the third party or outside they'll
On the
put it.
other mission like that we can maintain.
So will that even work like that? Even see
Yes,
now
yes,
that
because even when I'm talking about auto scaling kind of thing also, I said don't keep on the database on the same AMI.
ఎట్లా అంటే the other day we kept S3 for the state file. This way we can.
Not like that. etcd itself is a NoSQL kind of database.
Okay.
It's not a RDBMS, but it's a NoSQL kind of database.
Okay.
Okay, so nowadays there are some alternates also coming from etcd also.
Okay.
Okay, that means not mandatory etcd itself. There are some other NoSQL kind of databases also is supporting, but mostly we are using
etc.
etcd itself. Okay, so then like a API server will communicate with the kubelet. Then on top of that, so to run the parts, definitely we require container runtime is mandatory. Okay.
Okay.
So CRI is nothing but container runtime. To expose this, to access the parts, all this from the node side, we can access through Kube-Proxy itself will provide the route for all this. So there is one service discovery kind of mechanism. That's we'll discuss how we can access these parts to outside. Okay. So
Okay.
these all almost around 8 to 10 components we have, right? Everyone should be able to tell that.
సార్ మనం ఇప్పుడు కుబర్నెటిస్ నేర్చుకుంటే వి డోంట్ హ్యావ్ టు గో ఫర్ ఈకేఎస్ జీకేఎస్ ఈకే
Yeah, yeah. Anything is fine.
ఇది నేర్చుకొని సరిపోతుంది.
Yes, yes. Anything is fine. That's managed. That's it.
ఓకే.
Say MySQL we have deployed on AWS or Azure or anywhere. MySQL commands are same.
ఓకే.
Okay.
ఓకే.
So if you manage EKS, AKS is even easy. GKE also good documentation is available. Easy to manage that.
ఓకే. Sir, one small question is,
Yeah.
it's we are able to do most. We are able to use in the interviews also. We are able to say that we are using most of the AWS microservices. When it comes to Azure, is it Azure DevOps and very less
No, no. In Azure
microservices?
DevOps also we have AKS only is now leading.
అంటే ఇది ఒక్కటని కాదు సార్, ఇన్ జనరల్ ఇంటర్వ్యూస్లో అడుగుతున్నారు కదా, అంటే గూగుల్ నుంచి ఇప్పుడు మీరు జీకే చెప్పినారు, జీకే ఇస్ వన్ ఆఫ్ ద గ్రేట్ డేటాబేస్లు బాగున్నాయి, అది ఏమంటారు జీసీపీ నుంచి, సారీ.
Yeah, yeah.
ఇంకా వాట్ ఆర్ ద అదర్ మైక్రో సర్వీసెస్ ఫ్రమ్ జీసీపీ ఆర్ వెరీ గుడ్ విచ్ వీ షుడ్ యాజ్ ఎ
No, no.
డెవాప్స్ ఇంజనీర్
GCP related more AI and ML solutions are good.
ఓకే.
AWS wise, almost all are good from the infra side.
ఓకే.
Azure wise, we have DevOps, Azure functions, mostly that suit for the .NET kind of things.
ఓకే.
Okay.
ఓకే సార్. సో టుమారో విల్ హ్యావ్ డే
Yeah,
వన్
yeah.
ఆఫ్ ల్యాబ్ ఆల్సో.
Yes, yes.
ఓకే సార్.
Okay. So now, like just go through this documentation also. We're not done. We'll discuss more things.
సార్ రేపు కుబర్నెటిస్
No, no.
టెరాఫార్మ్ చెప్తారు.
Today not done.
ఓకే.
Okay. So now, in the Docker command line tool is Docker itself. Mostly we use Docker pull, Docker search, Docker run, Docker start, stop. Like this, we have the Docker is the container runtime, right? Sorry, Docker is the command line tool we use. But in the Kubernetes, the kubectl is the command line tool.
ఓకే.
Okay, most of the things we need to use from the kubectl itself. Okay, so that means we should have very good knowledge on the kubectl to work in our daily job.
ఓకే.
And even for troubleshooting, for optimization, for deployments, all these also we need kubectl. What exactly the kubectl is?
Is the
The
CLA tool for
kubectl is the
Kubernetes.
command line tool, which when we hit the kubectl, apply something or maybe create something, run something, it's going to communicate with the API server.
Okay.
And whatever the instructions we have given, that instruction API server will listen and will provide the details to the kubectl. Okay, so I hope get nodes will list all the nodes. If I have 10 nodes, it display those.
Okay.
Okay, so then kubectl get parts.
It
This
lists
is in
all.
the Docker PS kind of command, equivalent kind of thing.
Okay.
Get all will show all the resources. Like this here, we need to have the kubectl is one of the command line tool we have.
Okay.
Okay, then kubeadm is also one of the command line tool, but that is used for the bootstrapping of the cluster. What is the
And
meaning of bootstrapping of the cluster? Is in the Docker we use Docker Swarm init, right? In
అంటే
order to
స్టార్ట్
initialize that is called as bootstrapping.
ఓకే, బిల్డింగ్ ఫ్రమ్ స్క్రాచ్.
Yeah, yeah. So supposed to bootstrap your Kubernetes cluster, we are using kubeadm. Okay, so to run the commands, all those we are using
First init
kubectl.
kubectl. Okay.
Okay, so cube ADM is one command line tool, but
No,
that's we don't
initialize
use every day. And even in the EKS, AKS, that's bootstrapping also is taken care by.
kubadm.
No, no.
ఎందులో అంటున్నారు?
In the AKS, that's Kubernetes itself will take care.
Okay, they have their own bootstrapping.
Yes, yes, that's they will take care. We no need to worry about
EKCTL అట్లాంటిది కదా సార్?
EKCTL is there.
Right.
For
Okay.
AWS we have.
Yes. Sir, certificates thing didn't have
Certificates
that.
is nothing but whenever the kubectl want to communicate with API server in the production,
Mm.
we'll have some certificates also. Without having that certificate, we can't authenticate that. Okay, so while bootstrapping that, will generate the certificates also. Okay, so without having the certificate, what is the problem is that API server can't authenticate. We'll have a token, all those, but in the real time, we'll have the certificates also. Okay, so where we need to have the certificates is from the kubectl, you should have the certificate, then only it's going to authenticate.
Okay.
Okay, so then very important component we have another one is
Same.
Kubernetes CNI. So this is also very important. Kubernetes CNI stands for network interface. Okay, container network interface. And for the networking, definitely we need the CNI. Okay, and there are a lot of third-party companies has developed the CNIs for like a Kubernetes. Okay, so by default, we are not getting this in the Kubernetes. There are a lot of companies has developed their own like set of plugins, and even in AWS we have VPC level, we have the CNIs. For Azure VNet level, we have our GCP level, GKE level, we have the CNIs. Okay, and even there are some third-party companies also has developed a lot of CNIs. Without having the CNI, if I keep kubectl get nodes, most of my nodes are in the not ready state. Okay, so that means master a node, most of the communication is going to happen. Okay, so with the CNIs and to get the IP addresses also. Normally at the VPC level, we are giving the CIDR range, right? Now even to each and every pod also, we are getting an IP address and we can enforce the network policies. A complete a complete cloud-based networking what we can get from VPC. Okay, we have now in the Kubernetes also.
సార్ మీరు ఇందాక క్యూ ప్రాక్సీ విల్ టేక్ కేర్ ఆఫ్ దిస్ అన్నారు కదా
That
సార్?
is only for routing, but definitely at the cluster level we require the CNI.
For the whole total
One time
networking.
setup.
Mhm.
This is one time we need to set up this.
Okay.
Based on the CNI, our network features will come.
Okay.
There are a lot of CNIs are available. Okay, so which CNI we need to tell also in the job also people will ask us. Okay, so these all the different companies has provided Calico, Flannel, View. Can you repeat these three names? You should remember
Calico,
these three.
Flannel, Wave.
Calico, Flannel,
Wave.
View is there. Okay, so there are other type also, but in AWS also we have AWS VPC level CNI, we have Azure level, we have the CNI. Okay, so it depends upon our requirement, we need to use this. And what is network policies, we'll discuss. So as of now, too early. Okay, so definitely, like if it is a small cluster, better to go for Flannel. But for the production on premises, you can use Calico. In AWS EKS, you are using AWS VPC CNI itself, we are using. In Azure also, Azure VNet CNI will use. Okay. So, but in your project, in whenever it is on premises, you can tell you used to work on Calico kind of thing.
Calico. Okay, production grade.
Okay. So this code, say here we are getting this YAML file, right? Who is
Yes, sir.
giving this YAML code? Calico.yaml.
Cali-
We
Calico
no
is
need to give. That has been given by
Calico.
Calico itself. That
అంటే
just we are
ప్లగిన్
using that.
ప్లగిన్ అంటే ఇదేనా సార్?
Yes, yes. That's
ఓకే.
YAML they're giving, and just we are giving that path from apply, we are deploying.
ఓకే, గాట్ ఇట్.
That's you no need to develop that. That's Calico is the big company. They develop that.
Okay, sir.
Okay. So networking, all that we need to have the CNI. So communication between the container and nodes. First, if you have the CNI, then it expose the route to that Kube-Proxy, and Kube-Proxy will route to to the pod. That end to end, we'll discuss that.
Okay.
Okay. So then on top of the CNI, these three you can remember, right? At least
Yes, sir.
Calico,
Panel,
Flannel, View.
wave.
I think I copied 2 times. Then very, very important another component is namespace. Normally, when I starting the Docker, I said about Linux namespaces we have, but these are the Kubernetes level. We have the namespaces. Say we have assume we have a very big floor is there, but we are partitioning by the flats, right? Maybe 4 flats or 5 flats. If I purchase maybe around 2000 SFT, builder will give me 2000 SFT only, right?
Yes, sir.
For other in the same floor, maybe another guy purchase 1600, he will give 1600 kind of thing. That means it's a physical wall or virtually we have.
Virtual.
No, it's a physical.
Physical wall. Sorry.
Okay, but sometimes we may have a partition also, right? This part is mine, this part is mine. Okay, in the
Yes.
same way, we have the cluster, but I'm allocating the virtually multiple clusters I'm creating, because the same cluster need to be used by multiple teams, multiple environments. Then we need to create the namespaces. If I don't have the namespace, what is the problem I'll get is maybe my production team would be telling Dev and QA are using the complete resources of the cluster. I'm not getting
Anything. No resources.
no resources for my pods. Okay, that problem we may have or not.
Yes.
That is the reason we are creating the namespaces. Okay, it's a physical or virtual. It's a virtual or logically itself we are going to group that.
Okay.
Okay, it's logically or maybe virtual clusters kind of thing. Inside we are creating again namespaces. Okay, what is the advantage of the namespace is if I have the 2 projects, how many namespaces I can create?
Two.
2, but technically for 2 projects, I'll create around 6 to 8. I'll tell one use case. For one project, I have dev environment, QA environment, and production environment.
Yeah.
And for second project also,
Same.
so like this, I'm creating almost 6. If I have a staging environment also, that also I'll create one more namespace. And my for my developers, I don't give the access to my QA and my production environments. Always it's very risky to give the access of production environment to the developers.
Okay.
So what is the promise or commitment from us is we'll give only the logs to him. Okay. So that means I don't give that access because even production also in the same cluster. But if I have the multiple namespaces, only for dev namespace, I'll give the permission to developer. Okay. So like this here, we have a lot of advantages by using the
Namespaces.
namespaces.
Least privilege అంటున్నారు కదా సార్ ఇందాక.
So we can give even that least privilege also we can give because dev for the other environments I'm not giving the any access, right?
Yes.
Okay. So now here what is the command we can use is kubectl create namespace,
Okay.
or we can use the YAML also, but that we'll discuss.
Okay.
So what is this here? This command also is very, very important. What is this? Kubectl config set hyphen context current namespace is dev underscore team. That means default I'm setting that namespace itself. By default, if I don't specify, by default, how many namespaces I'm getting is almost 4 namespaces I'm getting. These 4 also we need to remember. Okay, that means we just created a Kubernetes cluster. By default, we are getting 4 namespaces. But on top of this, we are creating our own,
Personal
yeah, our
namespaces.
own project related or team related namespaces also. Okay. But one more important question from the interview is like what are the namespaces by default we are getting?
Kube system public
Yeah,
nodes.
default Kube system, Kube public, and node release. So now what is the default we have is if we don't create any project related or team related, environment related namespaces, all will go to default itself.
Set context.
But that is not recommended. Okay. So that's if you want to change to your own, then you can keep that set context. And internal Kubernetes also will maintain a lot of workloads. Maybe for API server will have one pod, scheduler will have one pod, etcd will have one pod, Kube DNS. There are a lot of components. Those are internal Kubernetes components. Those are not in the default namespace. By default, those are running on Kube system kind of thing. Okay. Say internal Kubernetes related components all are running as the pods itself again. But those are running under which namespace?
Kube system.
Kube system. And public not that much important, any readable kind of things, all those we don't use Kube public. But node lease is track the heartbeat also for the any of the node detection like this we are going to keep. These all the four we need to remember, but two are important, default and Kube system. But we are creating our own namespaces also. Okay, so what are the use cases why we'll go is we have the multiple teams in the same project or multiple projects itself we have, and I want the isolation between the multiple environments, and I want to give the resource quotas also. So total I have around 64 virtual CPUs and 64 GB RAM I have. So maybe I have around 4 nodes. Then what I want to do is for dev environment I don't want to give 16 GB. I want to give only 4 GB, 4 GB. For QA also I want to give 4 GB, 4 GB. Remaining all I want to give for my production itself. If I don't give this kind of quota, what is the problem we'll face in the production is dev and QA will use all the resource quota. Then at the application level I don't get.
Anything in production for
That is
production.
the reason even this kind of resource quotas also we can give. What is the advantage is developers can't use more than that 4 GB or 4 CPUs. What is the quota I have given? Okay, so that is also one of the by default we don't get, but we need to attach this. Okay, so this is also the advantage of using, and even permissions also we can give role based access, and between the parts also because my dev part don't want to communicate with my production part at all.
Okay.
That's we have the network policies that CNA will give the network policies, but that's we can restrict at namespace level communication, IP address based communication also we can restrict by using the network policies. And access control also for developer, I don't want to give the access to my QA namespace or production namespaces. For that also I'm going to use RBAC kind of things also we can enforce. Okay, so that is the concept of
CNI
namespaces we have.
Kubernetes namespaces.
Okay, so definitely in the production we'll have the multiple namespaces and we need to work on those namespaces. Logically, like it's going to provide a virtual cluster for us. Okay, so
Oh,
this and minimum 2 to 3 videos which we shared in that one, everyone need to finish
which one, sir?
in that
Kubernetes.
playlist. Yeah,